So we're looking at moving on to force verification. So we've taken care of air cuts only and OptiPath only. So we had air cuts, which is only manipulating cuts that are not inside the material. We've got OptiPath, which is user-based, working with chip load and volume removal, has no knowledge of material type or cutting forces. Force, on the other hand, is what we call a physics-based optimization. So it's got information that is related to a cutter specifics, the helix, the rake angle, material specifics. We have cut material such as titanium and Inconel and hard steels and soft materials, aluminums, and we gather that information, the forces that are being used when those materials are cut, and we bring that into the physics-based force optimization. We can utilize spindle power. We've got gauges for maximum allowable feed rate, that kind of stuff. We can check for cutter deflection. So there's a lot of options inside of force that you don't get with OptiPath because you don't have knowledge of the material or the cutting tool itself. In OptiPath, you know that you've got a tool, you know the diameter and length of it, and you know that it has X amount of flutes. In force, we know that what the helix is for those, so we know more information regarding that. Force is also a modular item inside of VERICUT. So you need a force module to be able to run force inside there. So how does force work? I mean, looking at this image here, you can see that on the left side, typical, when you key in your CAM system and you're taking a particular chip load, it thinks you're taking a full cut of the part. So you get a full chip load. What it doesn't know is what happens when you're actually not taking a full width cut. We call that chip thinning. So we know optimization force knows when it needs chip thinning, and it can speed up and correct feed rate optimization based on chip thinning. So let's talk about physics not complicated. In this image here, we've got a lot of the things that are familiar with programmers and machinists. It's material hardness, the cutting tool, what is the chip load range, information, horsepower, torque. These are all of the calculations, the formulas that get all thrown into this big mix we call the physics of how we're going to cut that. And as you can see in the crosshairs, that all happens where the tool intersects the material. As with OptiPath, where do we start from here? We need the information based on cutting tools. We have to gather that information. We need to know what the capabilities of that tool are. Again, we can start with the machining cloud. As I said before, lots of this information is available. You have to go look for it. Now, looking at this information here, material type, cutting tool type, we've got the helix and rake angle inside this information that we've gathered, so it's easy to put into the VERICUT tool force menus. But our goal is maximum chip thickness. We've found that that is exactly the best way to maintain a tool, a part, get our best material finish, have our tools last the longest. If we deviate from some of these, it causes the tool to wear out prematurely, or we don't get a good finish, or we've got chatter in the corners, different things like that. By maintaining a constant chip thickness, we eliminate a lot of those things. We've gone and cut material and used a dynamometer to gather this information. So it comes back in. When we run force, we actually bring in a force material data, a .vcfm file that has the information that was gathered during a cut on a specific type of material. We enter the tool information and the cutting material. The tool information goes into our tool manager with the helix and rake angle. Then we run force, and again, like in OptiPath, we have some optimization or optimizing aids that we can use to help decipher what's going on and how we might make this a successful cut. So as you can see here, here's a dynamometer. We've made the cuts. Depends on the type of material. We have 30 or 40 different material data specs already on hand. We can actually cut more if there's something that isn't in our list needed. This is the force material data spec showing you where we've cut some of the materials, the chip thickness that we use, the surface feet. And this is this information is exponential. We look at this and we say, although we did cut with a particular chip thickness from this value to this value, that doesn't mean that's the only values. We can still exponentially go out beyond that without having to cut another piece of material. I actually was able to see this process happening. It's amazing how sensitive a dynamometer is. It starts to move when the coolant comes on before the cutter ever intersects it. So each line on the graph is each flute intersecting the part. So inside the force settings window, you can see we have an area to key in this material. So it goes and finds that file that we've brought in along with it for the particular type of material that we'll be cutting with this. This information shows where we've got the helix and rake angle along with, is this a steel cutter? Is this a carbide cutter? Is this an inserted tool? So we've gone through and given you information or areas to fill in so we know more about the actual cutting process as we start cutting the part. So in the force settings window, we have directories for where these files are going to go, where they're coming from, as far as the material type files, how to start the charts when the process is ended or during the optimization. You can see that these fields are, it's a very small list of information needed to be input. Once it's here, it's there. It's not something you need to do all the time. Force initialization is successful. I would have filled these menus in and then gone in and ran my part. So optimizing aids, I mean, running force is basically you're running VERICUT, but you turned force on after filling in a few menus. So it's not, it actually, while it's cutting, it's actually optimizing at the same time. The charts are powerful, and they can show you a lot of information about what's going on during the cutting process. You can see here, I've got 3 different charts shown. I have options for more, but you can see the spikes in my blue, which is the original, and you can see where the line at the top of that is straight, where I've taken the spikes out by increasing the feed rates to give me a constant chip load. I've got interactive information on the left side that shows me what's going on during the cut. I can see both the optimized information as well as the what we call analyze, which is the original program. I can see it with one tool at a time, or I can see the chart with all the tools. You can see here I've got vertical lines showing me where one tool started and ended going into the next cut. At the bottom, I've got chart configuration options here where I can have a removal rate. I can show a chart that shows me cutter deflection or the machine forces or radial axial forces. I've got a lot of options in here, and this information is all useful. So looking at this, I can toggle off and on to see only the original analyze or the output optimized file. Original being the one here with the blue lines and the optimized with the red. And you can see that I've got limit lines, so I know where my chip load was set at, or I know where my force limit was at. So if I'm finding that I'm exceeding those information, I could change some of the values inside of force to correct those for me. It's a great graphical representation that you get here with the data display. It also has where if I run the mouse over this information, it actually shows me at any given time what the information is displaying. So I can see, if I see a spike, I could run the mouse right up to the spike and see, oh, this is what's going on. It tells me what line of code in my NC program, which, as you know, finding where an error is at is half the battle. If I can see that spike, find exactly what line of code it is, and then look and see what the information is, chip load, feed rate, that kind of information, I know where to go look and how to correct it. So seeing these charts and utilizing them is powerful. I've got the option, like I did in the interactive portion of OptiPath, to actually cut my part, see the charts, or select the charts and have it highlight in my NC program in that same review mode where my part and my optimization are both simultaneous, interactive. We also have the graphs as well as the status window, like we did inside OptiPath. Same information there. We can set limits in here. Let VERICUT tell me when I've hit a particular limit, whether that's a feed, a chip load, or whatever it needs to be. Let's do a force optimization demo. All right, looks like it's coming up. You guys should be able to see this now. So this is just a simple part. One, you saw it in a couple of the other options, some of the slides that I had there. I'm going to go ahead and go into Optimize Control, and this is where my force settings are at. So I would have chosen my material inside here. I can choose to analyze and optimize information here. And I can say, okay, I filled in a few of these menus that tells me where it's going to store some information that it's generating. And then prior to doing that, I would have brought up my tool manager to allow me to put in some specific information for my tools. So this is where my helix and rake angle gets put in, what type of material my tool is actually made out of. Is this a straight tool, straight shank type tool, or is it a serrated, mini cut, rougher type tool? We're looking for information. This is just some basic things we can put in here, not looking for, but filling in. What was the chip thickness that I gathered that from the tool manufacturer that said what my chip thickness or information should be on this? So I've got some other information here. Minimum feed rate changes. Harder materials versus soft materials would determine whether you want to jump at a 5/1000th increment or maybe a 1/1000th feed rate increment, just a 1 inch per minute feed rate. Just depends on what type of material you're cutting and how fast do you want to go when you're actually cutting here. Both OptiPath and Force optimize air cuts as well as cutting the part. So I've got OptiPath turned on for Force, and I cut this. My Force charts to show up here. Squeezed for a little bit of real estate, but I think I can make this work. We got the part cutting there. We've got the charts showing up over here. And I like to stop at this point when I'm showing this. I'm going to single block a few times here so you can see what these charts are telling me. As I come in from the right side of the part there, I drop down, and as I come into the part and start cutting, you can see that chart's going to move across, and as it dips into this cavity area, it's going to put a spike in my chart. That spike is where the volume changed, the chip thickness has changed. You can see the chart at the bottom is maximum chip thickness. The one up at the top is force. And I've got the red lines at the top of these are the limits that I have set for these. So you can see if I turn off the original program here, you can see that I'm looking at the lower menu here, or the lower chart with the maximum chip thickness, because really, as I said, we're trying to maintain a constant chip thickness here. That's where the power is at. The force is a limit, so I don't exceed those things and break tools. I also have cutter deflection to help me with that. So by turning the original program off, which actually had this huge spike in where it dipped into the center area here, you can see that my optimized program, which is the one in red, has removed that. If I were to compare the two files now, I could see that those feed rates have sped up and slowed down as needed to maintain that constant chip load. I can let this thing cut across here. Got information that is in the data display area to the left side here. As I run my mouse over one of these spikes or any information, I can just stop it there and it'll tell me that information where this is coming into a play. speed this up. Takes about a minute at the most to run this little part, but you can see that the charts continue to go across. I can stop at any time, analyze, I can zoom in on this. Like I said, the information that it feeds back to you, where did this spike happen? Where is this coming from? I can go into my review mode. When I turn on review, that allows me to then go back into this a little bit at a time and actually watch what's happening, so I can cut the part a little bit and see what the actual results are. Very powerful. Here's my savings calculator. Close that up. I can go in, I can watch review, I can check my part. Wants to take my post-process or my new output optimized file and replace it. I'm just going to say no. But this is how Force works. It has the information. It knows what type of material. We've cut a piece of material. Got that information in there. Knows exactly what's going on.